Problem number 47 of section 1.4.1 is a chemistry problem. We're given two molecules A and B that combine via a second order chemical reaction into a third molecule C. Now we're given the initial concentrations of A and B, and so we have small a is initial concentration of A, small b is the initial concentration of the molecule B. And we're given a formula that describes the concentration of the third molecule C at any given time. I should say, actually, this should be the derivative of the concentration. So the rate that the concentration of C is changing is equal to this formula, which is in terms of the initial concentrations of A and B, and the concentration of the molecule C at the given time t. So our first question is, well, what if our initial concentration of C is 0? So we just have molecules A and B, and they haven't started to combine to form the third molecule C yet. Well, then is the rate of change of the concentration of C greater than 0, equal to 0, less than 0? Well, let's look at our formula here. We know that C of 0 is equal to 0. So we can just stick in, or substitute in 0 right here. So we have C of t, or excuse me, C prime of 0 is equal to 4 times, well, A minus 0, and similarly B minus 0. Now, the one actually part of the problem that I forgot to write on the board here, which makes intuitively makes sense, is that the initial concentrations have to be positive. It can't really have a negative concentration of something. So right up here, assume that A is greater than 0 and that B is greater than 0. Also, it would make sense for one of them or both of them to be 0, because then we could have no reaction in order to produce the third molecule. So we have that the derivative of C at time 0 is equal to 4 times A times B. These are all positive numbers, so we know that it will be greater than 0. Part B asks, well, what if the concentration at a given time T1 is less than the initial concentration of the molecule A, but greater than the initial concentration of the molecule B? Can we say anything about the rate of change of the concentration of C now? Well, C of T1 is going to be 4 times A minus the concentration at time T1 times B minus the concentration at time equals T1. Now let's look at this one right here. We know that C of T1 is less than the initial concentration of A. So we know that C of T1 is less than A, which means that this whole thing is going to be less than 0. Excuse me, greater than 0. Now, similarly, we can look at the second part here, and we know that C of T1 is greater than the concentration of B. So we know that B minus C of T1 is going to be less than 0. So we have a positive number times a positive number times a negative number will give us a negative number. Now, final part of the problem says, well, what are the chemical conditions necessary for the rate of change at a certain point to be equal to 0? Well, that means that this formula here is going to need to equal 0. So 4, that's always going to be there. So we either have to have this part of the product equal to 0, or the second part of the product equal to 0, or they both could be equal to 0. So the conditions necessary are for the concentration of molecule C to be equal to the initial concentration of A, or for concentration of C to be equal to the initial concentration of B. And this makes sense because if the concentration of C becomes equal to, say, the concentration of A, well, that means that all of A has been used up and is now molecule C, so the reaction can't really go any further and C can't grow anymore. So similarly, if it's equal to B.